Geologists have dated the deposits associated with the Oligocene to between 38 and 22 million years ago. The term Oligocene translates roughly to a time of few recent forms. It was a time when there were very few modern or living animal forms that we see today. For our purposes here, we consider these Oligocene deposits and the limited forms that appear in them to be part of a very quiet time in the evolutionary record. However, it is an important time for the definition of true simians, in this case, living forms of ape, monkeys, and hominids. During the Oligocene epoch, we see quite a bit of populational migration, in this case associated with a changing climate. Physical geographers reconstructing these paleo environments recognize the Oligocene to be a time of temperature cooling, a time when grasslands as an important biome within the biosphere of the planet begin to expand, and a time when forest stands begin to reduce in size. Paleoanthropologists and paleoprimatologists recognize this Oligocene to be very important, as I mentioned earlier. We see in this case the appearance of two new fossil families, the Propliopithecids and the Peripithecids. Among the fossilized members of Pliopithecidae, we recognize one very important type fossil as it relates to future forms within the Primates order. In this case, our Egyptian ape, or Egyptopithecus zeusis. Let's take a moment here to take a closer look at this important type fossil. Egyptopithecus zeusis is a unique admixture of physical traits. When we look at its postcranial anatomy, we recognize it to be very monkey-like in its form and its size. Its dentition, however, is very ape-like. The dental formula for our Egyptian ape is 2-1-2-3. If we cut the face in half and we take a look at the dental count, that means we have 2 incisors, 1 canine, 2 premolars, and 3 molars. This 2-1-2-3 dental formula is something we recognize not only in ourselves, but other living hominoids. As we look at its lower cheek teeth, in this case the first molar on the mandible, we recognize a unique cusping pattern that is also very similar or shared among the living hominoids. In this case, it is referred to as a Y5 cusping pattern. Other dental traits include a fully fused mandibular symphysis, or an area of the mandible where there is a complete union between a left and a right half. We see a very deep jaw, a V-shaped mandible, and when we take a look at one particular tooth type, in this case the lower incisors, we have a very spatulate shape to their morphology. Given all of these characteristics, we would associate the concept of mosaic evolution to this type form. I generally recognize mosaic evolution as different physical traits developing at different rates. Another way to think about it is that we have a real admixture of physical traits or characters, some associated with living populations today, others very primitive in nature. The last thing I would like to say about this Oligocene deposit is that we have, at least in the old world, prosimians present, a living form which seems to best describe physically and behaviorally the prosimians of old world Oligocene deposits would be our tarsiers, or living members of the family Tarsidae. The next group of deposits that I'd like to take a look at in association with these changing populational forms associated with the Primates order is referred to as the Miocene epoch. The Miocene lasted from approximately 22 to 5 million years ago. A great deal of attention by researchers is given to Old World forms during this time period. There is fossil evidence for an adaptive radiation of hominoids, or a taxonomic diversification of hominoids, at the beginning of the Miocene epoch. The ape-like forms of the Miocene epoch that we will focus on today are referred to often as dental apes. Their dentition in this case is very ape-like. Much of what we know of Old World Miocene apes comes from Africa, Asia, and Europe. Today, paleoanthropologists and paleoprimatologists recognize 5 important type forms that will be potential contributors to the modern hominoids. Although you will want to remember the geographic locations for all 5 of these physical forms, in today's lecture we will be only focusing on one particular family, and within that family, one particular genus. Let's take a closer look at a dryamorph hominoid, a member of the fossilized family Proconsolidae, and specifically a member of the genus Proconsolid, Proconsol. The genus and species distinction that I would like you to associate with this particular fossilized form is Proconsol africanus. Proconsol africanus appears in deposits in the early Miocene. This dryamorph and the deposits that it's recovered from date to approximately 23 to as recent as 17 million years ago. Today, paleoprimatologists recognize 3 species within the Proconsol genus distinction. Let's take a closer look at some of the physical traits of this fossilized form. Proconsol africanus presents us with very narrow nasal bones. It presents us with eye orbits that are further apart than what we see in similar living populations today. It has a very hominoid orientation to its ethmofrontal sinus region. It has a reduced mandible, reduced canines, a single cusp on the 3rd premolar, very thin enamel, and molar crowns that have sharp, bony ridging and cusping. And I should mention that it also presents us, when we have now more data to look at, with an expression on a populational level of reduced sexual dimorphism. Following the Miocene epoch, we recognize another very important series of deposits, in this case associated with an epoch that begins at or around 5 million years ago. It's referred to as the Pliocene epoch. In this Pliocene epoch, we will see the rise of this unique form, the Australopithecine. Take a moment to review your taxonomic chart. Then, refer back to this particular slide. It is in the Pliocene epoch that we see the split occur between 3 important families within your taxonomic chart. In this case, the hominids. You are the only living member in this case, of the Hominidae family. Pongidae, which includes our chimps and gorillas. And Hylobatidae, which includes our gibbons and siamangs. Paleoprimatologists believe that this split occurred approximately 5 to 7 million years ago. For our purposes here, we'll be taking a closer look at the Hominidae family. In the Pliocene, we see 2 subfamilies of Hominidae. The first is the one that we'll be talking about today, the Australopithecines. We'll be picking up on the hominines in our next lecture. The earliest discovery of fossilized material associated with the Australopithecine subfamily is accredited to the work of Raymond Dart. In 1924, he recovers a juvenile member of this particular subfamily from the Tong Valley region. Today, this type fossil is referred to as the Tong baby. We'll be taking a closer look at an adult form that is associated with the paleoanthropological work of Robert Broom from the 1930s. Take a moment, however, to review this slide. Relate its content to your recent readings. Now let's take a look at the adult form of this Australopithecine. In this case, this type fossil is referred to as Australopithecus africanus. When we look at the Africanus material as a whole, we recognize that on a populational level, sexual dimorphism is reduced. Females, in this case, were on average 4 feet tall, weighing between 55 and 66 pounds, while males averaged around 5 feet in height. Their projected weight would be somewhere between 90 and 132 pounds. The canines, whether female or male, for these slender apes were reduced in size. Their dentition, both in the upper and lower dental arcades, had a parabolic shape to its overall orientation. You can think of a parabolic shape as similar to an arch. The postcranial anatomy of Africanus expresses longer arms and shorter legs, very different from what we see in our own species or subspecies today. When we take a look at its tibia, for example, this would be one of the 2 bones of the lower leg. It has a very ape-like expression to it. The diaphysis, or bone shaft, is somewhat curved. Paired with this, we see the expression, or the retainance, of a large grasping toe. And a new trait, in this case the pelvic region, is not as ape-like as we would anticipate. It is wide and bowl-shaped. Another gracile or slender ape that we should mention in relation to the Pliocene epoch, in this case appearing in deposits deeper than the Africanus material, is Afarensis. This type fossil of Australopithecine, referred to in this case in terms of its genus and species distinction as Australopithecus afarensis, was discovered by Donald Johanson in 1974. Donald Johanson named this very unique fossil form Lucy. Australopithecus afarensis, as a population of fossilized slender apes or gracile apes, presents us with a very unique admixture of physical traits. Sexual dimorphism is well expressed in these populations. Females, in this case, were slightly over 3 feet tall, and projections for average heights among males would have put them at or around 5 feet in overall height. This is paired with, in this case, weights for females of upwards of 70 pounds, while males weighed between 100 and 150. This puts our sexual dimorphism at a projected 70%. Composite estimates of brain sizes for the afarensis material are projected at or around 430 to 433 cubic centimeters on average. The cranium in this case was characterized by the presence of a good amount of facial projection or prognathism, a low flattened forehead, a low vault to the brain case, large brow ridges, and an unflexed cranial base. Finally, the last thing I'd like to share with you with regards to the cranial morphology of afarensis material relates to the dentition. Like Africanus, afarensis presents us with a parabolic arch to the upper and lower dental arcades. Slender or gracile Australopithecines are not the only part of our story when we take a look at Pliocene deposits. There are robust or large forms, best represented, I believe, by Australopithecus boisei. Discovered in Olduvai Gorge by paleoanthropologist Mary Leakey in July of 1959, this robust expression of Australopithecine is so unique that some paleoprimatologists recognize it to be of a different genus distinction, in this case, Paranthropus. For the purpose of this course and course offering, we will recognize the robust forms of Australopithecine to be part of a single genus that is also shared by the gracile forms, in this case Australopithecus. Let's take a moment now to take a closer look at this Boisei population. A lot of what I will be talking about in this slide and the next slide is representative of a composite reconstruction of these populations. And much of what I'll be talking about can be applied to other robust forms, robust populations in this case, of Australopithecine. When we take a look at these robust populations, specifically Boisei and the discoveries of the Leakeys in East Africa, we recognize that many of these forms have been found in paleoarchaeological association with flake and chopping tools. This is important, especially when we're taking a look at the cognitive abilities of these slender apes. The dates on the deposits that robust populations have been recovered from range between 2.3 and 1.3 million years ago. This brings robust populations up against the emergence of a new group that we'll be taking a look at in our next lecture, the hominins. Robust forms of Australopithecus express a pretty good amount of sexual dimorphism, but it is greatly reduced. In this case, we recognize females for our Boisei populations to range between 75 and 100 pounds, whereas males range between 100 and 180 pounds. They are much larger than our gracile populations. With this larger body type, we see a corresponding enlargement to their cranial capacity. In this case, averages for Boisei populations place us at or around 500 cc's. Other cranial traits associated with Boisei include the following. A dish-shaped face, very different from what we see with our gracile populations. A strongly expressed sagittal crest. That's that bony ridge or crest that you see in the previous slide associated with the sagittal region of the skull or the top of the skull. We recognize a low forehead, and we recognize some flexure to the basocranial region. Flexion to the basocranial region is a uniquely bipedal trait. The dental arcade of robust populations, in this case the Boisei composite group, is parabolic in nature. Incisors and canines are small, and the molars themselves, the chewing surfaces of the molars, are quite large. However, the cusping patterns for the lower and upper molars are a little bit different, in this case expressing patterns of 3 to 4 cusps. The postcranial anatomy and physiology of these robust populations, very similar to what we saw with regards to our gracile Australopithecines. The postcranial anatomy of Boisei populations express elongated arms and shorter legs, a wide and shallow pelvic bowl, coupled with, in this case, shortened and more broad iliac or pelvic blades. A final comparison made between gracile and robust Australopithecines tells us the following. First, that robust populations were very well adapted to the widening grasslands of the Pliocene epoch. The second characteristic I'd like to share with you regarding these robust populations is that their dentition and the muscle structure and ligament attachments associated with many of the muscle groups associated with mastication were much more robust than what we see with our gracile groups. This means that their foods would have been commonly tough in nature or very fibrous in nature. And then finally, the last thing I'd like you to associate with this robust population is their physiology allowed them a greater ability for bipedal locomotion. These characteristics may have allowed the robust populations to thrive in the Pliocene grasslands. However, when we look at what comes next in terms of the fossil record, they don't seem to be as well expressed in the next epoch.